by fission. What do you mean by fission? Where a heavier nuclei will split up into two lighter nuclei. That's called like a fission. So basically, what is a fission? If a heavier nuclei is there, it will break up into two lighter nuclei or middleweight nuclei. So call Z1, A1. So there's a heavier nuclei. Breaking up of heavier nuclei into two middleweight nuclei is called like a fission. Fission means breaking up into two parts, two or three, more than one. You can better put it. And now is asking to get the value of Q. What we have is binding energy per nucleon, and this is a mass number. When energy will be released, go back. Till now we discussed about the only mass, no? Only we discussed about the mass. If the mass of parent minus mass of daughter, if the difference is positive, energy will be released. If you have binding energy, what you should do? Binding energy of daughter, if it is more than that of parent, energy will be released. This is a basic idea. Okay, now is asking, based on the consider nuclear fission reaction, W becomes X plus Y. W becomes X plus Y. Based on graph given shown, binding energy per nucleon versus number of, answer the following. And what is the Q value of the reaction? So W is what? There's a parent. And X and Y, what happen, will become a daughter. X and Y will become a daughter. And now what is the binding energy? Binding energy per nucleon of parent is how much? E1 per nucleon. How many nucleons are there? N1. So shall we write E1 into N1 will become binding energy? Go back to the concept. Energy will be released binding energy of daughter greater than binding energy of parent. Will I agree this? See, that is mass and binding energy. These are the only two information. But sir, we have binding energy per nucleon. Can we calculate binding energy? Yes, we can calculate. What is the binding energy of the daughters? We'll calculate first. Binding energy of daughters will calculate. Binding energy of where are the daughters? X and Y are the daughters. Huh? This is the parent. X and Y are daughters. For the reaction, W, X plus Y is asking. Okay, I'll proceed like this. What is the binding energy? So daughter X will take it. What is the binding energy per nucleon? E3, and number of nucleons are N3. E3 into N3. Plus next again daughter Y, E2 into N2. What is the binding energy of parent? Binding edge of parent. Binding edge of parent is W into N1. Sorry, E1 into N1. So what is the equation you can write? Energy will be released when E3 N3 plus E2 N2 minus E1 N1. No? Now, which equation will satisfy? Let's write some. Is it E3 greater than E2 greater than E1? Which energy will be greater? Binding energy per daughter or this one? So binding energy per daughter is greater than binding energy of parent. So is it from graph? Can we conclude anything? So shall I directly go for these two are ruled out? I think the problem with only option A and B, which one has to be picked up? But sir, Q can be negative or positive. Q can be positive or negative. So when you move from left to right, what's happening to binding energy? The binding energy per nucleon of daughters are more than that of parent. So definitely energy will be released here. So therefore, the option B is what I'll pick up. Agreed? Now I'll give one numerical bet on this. We have a graph. At least I think this will be much easy for you. This is a binding energy per nucleon versus nucleon. Assume that binding energy nucleon, plot this one. Fusion of. What do you mean by fission and fusion? Fusion means where they combine. Fission means where they will break up. First, we'll get into option A. First, option A, is it right or wrong? We'll check it. Option A, fusion of two nuclei with mass number lying in the range of 1 to 50 will release energy. Can we pick up 1 to 50? So what is the binding energy of that? 2. How to calculate Q? Q should be like a 2 nuclei you pick up. So what is the, I'll pick up the mass number. Let me pick up the two nuclei, no? So parent, it will be X plus Y, Z. So let the X be the 20, Y be 30. Even the Z is also formed. So what will happen to Z? Fusion of two nuclei with mass numbers lying in the range 8 to 50 will release energy. So when energy released, when binding energy of the daughter formed is greater than that of parent. So now how to analyze this one? I just picked up. Okay, I'll do one thing. 10, 9, 15 will take it. It'll be much easier. Let me pick up one. Like a parent X of mass number 10, number of nucleons, let it be, or mass number 10, and next another parent of mass number 15. What is the binding energy per of that? So it will be 10 into, so 2 into 10. Then how much will get here? 2 into 15. We know number of mass numbers should be there. So 2 plus 2, what you get? Overall mass number. So I think chemistry, you go for equation. Overall the mass number of nucleons should be conserved, no? So we'll get Z equal to 4, no? So the 4 will come here.
25, sir.
Oh, sorry. 25 will come. Oh, so sorry. This will be 25, no? Yeah, 25. 25, what happened? Where do you lie? It will lie here. It will lie here. So then what will happen? This is the binding edge of parent, will write it. Binding edge of daughter. Daughter should be how much? 25. Check it now. So this will be how much you'll get it? 20 plus 30. Now, energy will it be released? Less than 50 is telling. Okay, I think what I assumed is correct. So what we are getting here now? No energy is released, no? When energy will be released, at least when binding edge of daughter is more than that of parent. So shall we rule out this option? Next again, fusion of two nuclei with mass number lying in the range of 51 to 100 will release energy. Fusion of two nuclei. So here what we should do, 51 and 100. 51 and between 100 is there. Now next option, X plus Y, let it be Z. X, let me assume between 50 and 100 is there, no? So let me assume 60. Y, let it be 70. What is the energy of this binding energy of parent? So that also only 2, no? So 2 into 60, 2 into 70, 120 plus 140, 260. What about the daughter? Daughter form will be 130, no? 130, where do will come? 130, it will be at 8. Yeah. 8 into 130. Anybody? Value of this? Why I should write 8? 1040. Look at no. The binding energy of daughter here is greater than that of parent. So possible. Yes, the reaction is possible. So above reaction is possible. So I'll pick up this. So there's a method of fusion. Fusion we are taking. There's a method of this one. Fusion means where the two nuclei will combine. Now you have to ask questions. Why you are writing 130? I think number of nucleons should be remain same, no? Chemistry, okay, fine. The total mass number should remain same. Let's check the option C. Fission is telling. Now fission means breaking up. Fission of a nucleus lying in the mass range of 100 to 200 will release energy when broken into two equal fragments. Okay, it's helping us. Two equal fragments. I'll discuss the option C here. Mass number. So let me take around 160 will break up into this one. The X will break up into Y plus Z. What is Y? Y, let me take 80. Mass number, let this be 80. So this should be how much? 160. Let's calculate the binding energy of, this is a parent, and these are daughters. Before entering into fusion, in your head what will happen? Binding energy of the daughter more than that of parent, energy is released. Mass of the parent more than that of daughter, energy is released. If you have this much, I think this topic is over. So we'll calculate now first the binding energy of parent. What is the binding energy of parent? We'll get 160. 160 means where do you lie? 160, I think binding energy per nucleon is 8, no? So 8 into 160. Anybody value?
280.
2?
And 280.
1280. Next, binding energy of daughters. Y is 80. Binding 80 means I think binding energy will be 2, no? So 2 into 80. 160 plus 160. Is it possible? Look at the binding energy of daughter less than that of parent. So not possible. Getting the idea? This is very important. Do analyze. Rest all again how we did in alpha beta decay. No? Similar way what happened, we are going to write some equation and it's over. Only just small theories needed. The numericals you can really enjoy. Straightforward. Now last one. Fusion of nucleus lying in the mass range 200 to 260. X will become Y plus Z. So this is the parent. This is a daughter. 200 to 260. So let me take 240. 240, it will, when broken into two equal fragments. So let X be how much? Full screen not visible, everything. 240, then Y and Z will be 120. Now let's calculate the binding energy of parent. The graph is needed, no, for me. Binding energy of the parent should be equal to 240, 260 is how much? I think line where it will come. 4. 4 into 240. Anybody value? 960. Yeah. Binding energy of daughter. Where do 120? 120 will be 8. Anybody value? 1920. If you see from here, this will be greater, no? So what is the conclusion we can make it? Binding energy of daughter greater than that of parent. So therefore possible. So when they give graph, no, the method you have to analyze here. So whenever we go for that fission reactions or fusion reactions, we are going to check it, means whether reaction possible or not. Whether reaction possible or not, there's only alternative available for us. If they give mass of parent greater than daughter, then reaction possible. Binding energy of daughter more than that of parent is reaction possible. Agreed? So now we'll start some basic idea of the fission. What's the time? Let me introduce to the fission concept. I know in the fission, what happened? A heavier nuclei, so like a uranium, that particular thing, what happened, will break up into